Okay, well, who would like to start us off this week? Crickets. Dieter, you're the first one on my screen.
Yes, that's a good question. I always had checked my calendar, said, what have I done last week?
That's fair.
Last week were a lot of submissions with 2 papers, and then the one we're working on, we hope to make their progress. And the rest I'm still deeply involved in this integrating my code and the gradient into this consortium joint inversion framework. So we're getting there, but not there. And I hope sometimes in the future I can show or share some of that work, and they're happy to show some of it. But that's all below company barriers at the moment. Yeah. That's mostly that today. I think I really have to look at those maps. I think SOG implemented them in SimPEG, right? At those maps, because today and yesterday I actually had the issues of the gradient. You get it out for conductivities, but then you would like to have it for resistivities or vice versa, or you would like to have it on a log scale. And I think that's really where the maps you have in SimPEG are powerful, right?
Yep.
Yeah.
Most of the maps should be able to do most of that work for you. As far as conductivity and resistivity, most of them should be plugged in. It should know how to do one automatically without having to use a map.
Right. But if you want to do that externally, though, there is the reciprocal map that does that. So if you wanted to plug it in outside, you can do that. But all the EM and the DC codes do that under the hood.
Yeah. Yeah, but then for the gradient, it's not just the reciprocal, right? So you have to be a bit more careful there how to translate.
It takes care of all of the necessary chain rules and product rules and everything.
I have to look at that. Yep, that's my week, I think.
Dieter, I just got a kind of quick question. So the problem that you're dealing with is like with a lot of this marine problem. It's like so big. And like, do you have sort of good pathway that you think, how are you going to invert and even simulate those big data, like a big sort of simulation and inversion like that?
So the consortium, the inversion framework they have is a structural inversion. So there's just a few layers, blocks, basically, that can vary the property. So you have a couple of layers, but then you can put in blobs, like say squares or arbitrary shaped blobs. And then it inverts for the values of these structures, but it also can shift the boundaries of those. So it can adjust, you start with something and it can adjust that, but it doesn't do it on a voxel by voxel basis. That's kind of what we're working on.
I see.
And like this, it's sort of an abstract framework, and like this, in this current project, I take in gravity, EM, and NIP tomography.
I see.
These are the 3 things right now. Yeah, I think I shared once the abstract in the DEF or meeting channel of the EIG 2018, which describes a bit their inversion scheme.
Yeah. Interesting.
Thanks, Dieter. Sagi, would you like to go next?
Nothing particular. Dev, I'm still like handling all of those issues that you made for SimPEG L1D, and then jumping into that refactoring is on my to-do list. Pretty top, but yeah, it's a bit busy these days here. We're sort of wrapping up this project. And I'm mostly working on geostatistics in these days. So yeah, I'm using like what's called SGEMS to stand for the developed software. Mostly GUI based, but you can still do a scripting, and then there's a Python plugin, so you can do a bit of Python scripting as well there. But yeah, not very exciting. It's kind of fun, but on the SimPEG, I think at some point it'll be nice to have some geostatistical plugin that you can readily generate some realistic images. So you can then you can actually simulate with the SimPEG. And yeah, I think they also got some like stochastic inversion framework that might be interesting to plug in SimPEG later. I kind of played a little bit like a year ago, which I'm still a little bit pessimistic, but yeah, not sure what I'm talking.
Is that code on GitHub, Saki? Like, could any of us play with it, or is it internal?
It's not on the GitHub. It's on the SourceForge. So it's basically an executable, and I think if you want, you can compile. But I think it's written in either Fortran or C++.
Okay.
And then you have a GUI.
What is it called?
SGEMS, SGEMS. So the base package is a GSLib, but I think they develop further with more sophisticated algorithm.
I don't know if you've seen, this is on a related note, I'll drop this into the notes too. GeoStats guy from UT Austin, Michael Perch. He's got a lot of geostats code on GitHub. I've flipped through it. I haven't gone into things in detail, but there might also be some interesting things. I don't know have you looked at that, Saki?
I did. I think it's a bit of, I think what he did is mostly calling GSLib, and then he actually developed some of the 2D part in Python. So, but the bottleneck actually, a lot of 3D, like once you move on to 3D, it's actually quite expensive. Yeah. And what actually SM's good about it is quite fast. So even if you got like, I don't know, 10 million cells, it's actually durable. You can actually run 3D simulations, like what they meant simulations there. And they got a bit more sophisticated algorithm, like rather than just simple kriging or simple simulation algorithm. So yeah, at the moment, like that doesn't sort of serve my purpose, but I've taken a look. There are a couple others. I think there's geostat tools. I think some of them are in the like the Swan sort of page. Anyway, that's where what I'm doing in GeoStat. Not very exciting.
So there was I think today you received the issue of geophysics, and there was a paper for airborne groundwater in California somewhere. Is that this person you mentioned that might be good to work with SimPEG? Catherine or something like, I can't remember.
What was it? What was the name? I haven't seen the issue.
No, not an issue. A paper, a journal paper in geophysics.
Oh, really?
I'll look for it and will ping you. Yeah.
Okay. Catherine DeLuca? Is that Catherine DeLuca?
Yes, something like this, I thought.
If she wrote a paper, then I think she's actually like, if her is Catherine DeLuca, she's the one who's actually running that airborne project at Department of the Water Resources. So
yeah, okay.
Yeah, so I think she actually knows SimPEGs, and she's actually pretty positive about using open source for the larger project and make some sort of online tools and stuff. So yeah, it's on the radar, but I haven't had a chance to work on it. But I actually do have a time between August and October. So I had a chat with my boss, and she's pretty keen on developing open source and packaging up what we have done here. So between August and October, I could potentially use my 50% of my time to do that. So yeah, I think I'm going to jump in at some point, but I'm not sure that I can do this month, but maybe next month could be much more tangible.
Thanks, Sagi. Devin, would you like to go next?
Sure. So I haven't really done anything in the last week or so for this, but I did get around to putting up some issues. So I might just screen share and put up what I've got so far. So yeah, you should be looking at the SimPEG EM1D repository. I put the issues in there. And I kind of put 4 main issues, at least to start. So there was a couple of unstable solutions or solutions that we didn't have for, you know, the horizontal loop. We could only do it on the axis. And for the vertical magnetic dipole, we could not put it on the axis. So we have a couple of solutions that we'd like to have. But I think maybe the biggest issue and something that Soggy would be the most useful is on the waveforms. So really just deciding where it lives. Right now we have all of the stuff pertaining to waveforms kind of in several places. For simple waveforms, like if it was a step off or a square wave, there would just be an independent function that would let you put in times and then output the currents. Then for some known waveforms like the SkyTem 2015, you would basically call it and it would just give you back some structure with all the information in it. And then there's some known systems. Basically, there's some things where you can say, I want to put in these locations, it's this type of survey, and it outputs a completely finished survey object, which we don't really use that structure anymore. So there's just a lot of different ways of kind of defining either waveforms or particular time domain systems. And the big question is just, where do we want the waveforms to live? When we define a waveform, do we want this to be maybe a property of the source object? Do we want to define a waveform object like we do with the TEM problem, and then say each source needs to be attached to a waveform object? Yeah, this is just something that needs, I think, maybe a lot of cleanup, and we could probably use some decision making on it. So this is something I think Soggy would be probably pretty useful for.
In general, I think the reason why I sort of, it's just a history of like my trials. Oh, there's a simple parametric waveform that you can potentially use. But I think in general, each survey has a different waveform, even though you use, let's say, exactly same VTEM system or SkyTem system, they have a slightly different waveform. So I think as a sort of a learning and educational perspective, having a couple of like a representative waveform is useful. And I think that's probably what we have that can serve. But in practice, I think it'll change. So what's actually important is the current like actual waveform, the time discretization and the waveform. So that would be my first comment. So I think we can clean up those what we have now because it's sort of scattered. And yeah, for the second part, I'm not sure. I think the current structure, which is attached to a source as an object, I think it's. I think we could use that structure, but
okay. So you'd want all the things. You'd want all the things like, you know, base frequency and sampling, sampling rate, and there's a whole bunch of other properties that you used in these. These waveforms, these like let's see, like company specific waveforms, just a laundry list of properties associated with it. And so then you're talking about making that all of those properties of the source object. So I kind of thought maybe doing it the way we do for time domain EM, where we create a waveform object. And all of those properties are associated with the waveform. That might be the most SimPEG-y and organized way to do this.
Okay. Yep. I think I like that way. Like,
I would agree. I like that.
But Devin,
too.
that still allows each transmitter to have its own waveform, though, does it?
That's correct. Yep.
Yeah.
Yeah, you would just have your list of all the waveforms and then your list of all the sources and then just attach them all together like that. You could do that if there's a specific waveform for each one.
I mean, that basically mimics the structure of SimPEG, right? Like,
That's the
the
idea
idea
is
is that it should be close. Like, I mean, I like keeping them close together, so it's if you create a source and the source has a waveform.
Yeah, and there was some stuff that I guess I don't understand the background theory when you're talking about the dual. There was some of that stuff that I couldn't find a reference or documentation on, so I didn't really know how it's being implemented. So that would be a good thing to help me out.
Right. Yeah, I could do that. Yeah, just bug me. We can have a chat.
Okay.
So it is like a kind of, you have a dual transmission. So one is high moment and second is low moment. So you transmit like large power first and then do a small power. So you can actually have good resolution in the deeper part and as well as the near surface. So that's what they usually meant dual moment. And in terms of implementation, what you actually need is just a step response. And then once you got a step response, you convolve with the different waveforms. So computationally, it's actually not expensive. So the cost is actually convolution. So everything is already computed, all the frequency components, and you generate the step response first, then convolve it with the two different waveforms. So that's how it's structured. So I think it's still not sure you want to sort of kind of break that apart as two different sources, because I think it's sort of one. So I think it's probably need to think about how you want to do that. But as a first shot, I guess like I would consider it as a single source. But
yeah, I mean, this is kind of one of the benefits of defining a waveform object is you could define a standard waveform object and then you could define the dual waveform object.
correct.
One question with all of this, because I'm guessing that some of the waveforms that are in the EM1D code right now might be basically a duplication of what's in SimPEG. Are there places where EM1D can actually just import directly the waveforms that are in SimPEG? And can we think about, we don't need to do this right away, but waveforms that are in EM1D that are not in SimPEG, can we think about a trajectory for bringing them in so there's only one set of waveforms kind of in the SimPEG ecosystem?
Yeah, I thought about that a little bit. I didn't get too deep into it, and I'm sure there's some stuff that can get reused. But for the 3D EM problem, you define time stepping, whereas this, you actually define the times and then do a convolution. And so I didn't know how much stuff can be brought over. I'm sure there's functions like the function that would let you create a ramp off or something. I'm sure that function exists somewhere else in SimPEG. I'm sure there's stuff that we can reuse.
Yeah, but the convolution step, Devin, shouldn't be happening. Well, maybe I'm wrong on this, but I don't believe that is the waveform's job, right? That should be the simulation's job to ask what waveform it is. So the waveform shouldn't care what you're doing with it, right? We're still evaluating it either in a time stepping mode or in a convolution mode, but the mathematical definition of a half sign shouldn't care how we're going to use it.
They are still sampled functions. Like the waveforms essentially represent sampled functions. So it doesn't matter. Like it's the ones in SimPEG are sampled functions, just like these ones are sampled functions. So I feel like they should probably just all live in SimPEG because SimPEG EM1D already depends on SimPEG, right? Does it? I have no idea.
In some ways, yes, and in some ways, no. I guess my plan of attack for this was let's take the EM1D let's structure it like SimPEG is structured, and it's okay that there's some stuff operating independently, or sorry, that that might be duplicated that exists in SimPEG, and then when we move it over, then make decisions as to not making sure there's duplicate stuff. I thought maybe that would be a step that happens later.
I think we can merge that in at that, so we can actually use the same structure for so predefined parametric types of waveform, which SimPEG has, like a trapezoidal.
Maybe a useful step for planning is actually in this issue, Devin, maybe just if you wouldn't mind, documenting what are the current waveforms in SimPEG EM1D, and then do they exist in SimPEG? Because what would be great is if, as you're refactoring this, if like the trapezoid waveform exists in both, let's just, instead of re-implementing or changing the implementation or refactoring what's currently in SimPEG EM1D, instead just delete that code and use an import statement. So we don't need to necessarily move anything over to SimPEG right now, but basically just delete whatever currently is actually verbatim a duplication.
Yeah, that makes sense.
Excellent. Well, that's exciting, Devin. It's exciting to see this progressing.
Yeah, and so I think there was that, and then was there another thing that's worth mentioning at this point? Yeah, I mean, I had some comments on highest level organization, but I think we can fix that sort of afterwards. A lot of it was, making this waveform class and trying to move supporting functions out of the highest level. So there's a lot of kind of if statements, if it's this type of source or etc. And it would be nice to just have a function defined in there that says, compute the Hankel transformer, compute the integral, and have that happening somewhere else. I think the highest level could be cleaned up so that it's much easier to read, and then it's calling supporting functions as opposed to putting all of that in the simulation class. But that's I've got 4 issues there that I think cover the most pertinent items, and any involvement from you guys would be fantastic.
Thanks, Devin. Excellent. Thibaut.
Yeah, so went back. So among other things this day, I'm finally looking at the simulation class. I was really not involved in that, and I was keeping my code as it was for all the writing, etc. So I'm trying to merge my branch with the simulation with master basically at the moment. So should be okay. Like I just have to. There is just like when the file change name, that sometimes it's harder to track things. So that's it just requires me to do it manually, kind of. So while I'm working on that, and actually on that note, I have a question for you, Joe. Is how far are you on that source decomposition you were working on for DC? Is that already on master, or is that somewhere else where you were?
Yeah, it's on master.
Like source? Okay, nice.
It's on master just for the DC case, yeah.
Would that work for IP too?
Oh, it should, yeah. They all have the same bones, like those 2 codes have the same bones, so it should work. I haven't messed with it too much, but I can double check. I haven't tested it against IP actually, but it should.
Is that the miniaturized function, Joe? Is that what?
Yeah.
Oh, I see. It should work,
okay.
Thibaut.
Nice.
Yeah. It only helpful, I think it's not very helpful a lot of mining cases where you use a pole dipole, but if you got kind of dipole and lots of kind of redundant data, that'll be quite helpful.
Yeah, the pole dipole I didn't do much of an improvement, but
it's definitely useful for those winner type arrays and things like that, where it's a lot of repeated sources and a lot of repeated electrodes as sources. That like it has a use, but it's not useful for everything.
Yeah. Okay. Yeah. Things because I was I think one of the next thing I want to do is like to go back to a DCIP dataset I was working on before and kind of left on the side. So and it's a big dataset, so that's why I was wondering. But it's true that it's probably a pole dipole for mining, so might not be that helpful. But
I think it's still durable, Thibaut. John ran like lots of big inversions, so I'm not sure how big your data was, but I think it's probably durable.
No, John probably has worked with similar size data sets, so it's good. And that's kind of the thing too. I think now SimPEG is in a good shape to work with that, because I remember trying that data set years ago and it was just not practical.
Right. Yeah, as long as you don't store the sensitivity at them, I think it should be fine, I guess, for a relatively big size problem.
Yeah.
Yeah.
Yeah, sensitivity gets big pretty quick.
It is.
So when you have a big survey, John, do you do any sort of weighting with the distance, with the electrode, etc.? Or
I've been sticking with surface weighting mostly.
Yeah, okay.
That's a pretty effective job. I've been playing around with the sensitivity depth weighting, but the problems are so huge, it's not really like time efficient. So like we could have like so many inversions out by the time we calculate it, and then it's just or then we run out of memory or something when we're trying to calculate it. It's like
Fair enough. Okay, yeah. So that's where I'm heading to right now.
Excellent. That's exciting, Thibaut. Cool. John, would you like to go next?
Yeah, sure. Yeah, I kind of went down the solver wormhole here.
Oh, okay. I'm excited to hear what you came up with.
Yeah. So I'm kind of now I'm on it. That PETC, mumps, and the Pardiso. Pardiso, I kind of inquired a bit there, and like for me to get a license through my company, it's about 3,000 Swiss francs. And that's locked to one computer. It's not free. You can't just take it off the computer and put it on another one. Commercial license is like $30,000. But it works on Windows and everything probably pretty easy. Whereas PET-C and mumps, we might have problems if Windows users want to use it. I've convinced my boss to let me turn one of my computers into a Linux machine. So I don't know. I think with PET-C, you got so many choices. Like you don't have, like it has mumps and everything else. So maybe it'd be worth the time to put into PET-C so that you have choices. Whereas if we just go with mumps, it's just we'll have mumps kind of thing, which might be the one that like reading about it that people do love it. It's pretty good.
Have you tried messing with Conda4 installation of mumps on Windows? Because I know that it's available.
Yeah, I did, but I couldn't. I guess I didn't play with it much, but I couldn't find what version it was. It's the new versions after 5.01 or something like that, where the real speed ups when you can scale. Those mumps are the ones that we kind of want to target, or I want to target for sure. So now I'm just trying to build it. I was playing around with Windows here this last week, trying to build up any of these and trying like the Python stuff that they have for wrappers. And Windows is just not playing well. So I was just wondering what you guys would thought, like just the PET-C to put the time into that. Because then it has iterative solvers, it has direct solvers. I don't know, maybe it's worth the time to do that. And there's lots of cool ways to construct the matrices. Like we can utilize the sparsity. We don't have to store any of that information. It's really well-rounded project. The documentation that I've been through, it just might be a little bit time-consuming is the thing, writing all the wrappers.
John, were you using PET-C for Pi or like directly PET-C?
Just PET-C as I was looking at. Yeah, I was just going to build it right. Just from when Dieter started that conversation, it seems like, everybody goes from the roots. They mentioned some of the Python wrappers, but I think if we want full control over what versions are being used, we should just build it right from the bottom.
Right. Yeah. I think we played a bit with PET-C for Pi a long time ago when we just started SimPEG.
Okay.
But yeah, it wasn't very promising because I think it's not well documented, and I'm not sure that PETC4Pi is actually ongoing project. It seems like
That's the thing. A lot of the
it seems kind of gone. So I think you're probably the right way to actually directly build that. And,
Sorry, I got caught out. I was asking whether PETC is still supported, where there's a large group that's working on it. What is the current status of it?
It looks like it's still really well maintained. Dieter, you know some of these guys who are working with it? Maybe.
No, but Octavio does, who is in this joint paper we try to do, and he says, yeah, they're coming out with new stuff soon, and I think this group is going strong. Yeah.
Yeah. The documentation as is, like for building up in Linux and whatnot, looks right up to date. Yeah, everything else is when you go down like the Python or the Windows side, then things are like back in 2000 or 2010. They've got like some Visual Studio projects, but yeah, it's not going to work.
Yeah. So PETC is actually like, it's a great ongoing project. But that their Python wrapper, I think it's sort of almost decayed, I guess. Probably very few people using. That was my feeling.
But yeah, it just looks like it has a lot of options, and I'd be, definitely DS would put in the time we would develop, because we want to be able to scale as well. And there's a lot of cool tools that come through there, like the Scotch and some other libraries that then you can visualize it much better. And yeah, I don't know, it looks pretty cool. Yeah,
and I guess with Lindsay, we saw in the comparison paper now that Octavio has millions of cells in his tetrahedral unstructured mesh and runs relatively fine on speed and RAM, where I think you are struggling now with Paradiso, right?
Yeah, definitely struggling. That would be excellent. I wonder, Joe, I don't know what your thoughts are. Is this like a good opportunity to actually create a repo that would replace PyMat solver or PyMKL, I guess. I guess PyMat solver is fine as is. But
PyMat solver is probably fine as it is. Like the point of that is just to make a solver interface to them and make it a nice wrapper. I think it's a good case for like switching out of PyMKL and along those lines. I mean, we can still support Paradiso easily enough. The wrappers that we can build would work for both versions, like the Intel's version and like the new Paradiso. They have the same handles and everything.
Yeah.
As far as PETC, like I would really like to look into it. Mumps, I know there's like Mumps like a Python interface for Mumps already, but it's depending on. I'm not quite sure. I think it uses the MPI version of Mumps.
Yeah, well, you can build it for different without it, right? But you technically need to build Mumps before to use the PyMumps anyways.
Yeah.
So yeah, you're building right from the.
Yeah, but I wasn't really just concerned about building Mumps because, like I said, it's on CondaForge. I think it's like I just looked; it was like version 5.1 or something. So, and they have it for all three operating systems. So I think we should be okay to depend on that, not have to worry about building Mumps ourselves.
Oh, okay.
Yeah.
What do you think the best like plan of action is there? Would it make the most sense, because Mumps is already on CondaForge, to start with Mumps and then start thinking about PETC, or?
Well, I mean, I'd imagine PETC is probably on CondaForge as well.
Oh, that's entirely.
I'd imagine.
Like
it's a very common thing. Like it's a very.
Yeah, I didn't think. Yeah.
Version 3.13 is on CondaForge.
Okay, excellent.
Huh.
Like we're fine to depend on any of these libraries and just go from there. I think the next thing is, okay, don't worry about building those libraries. So let's look at the existing Python wrappers for them and see if they are fit for what we want to do.
Okay.
If they are, then we can just use those directly in PyMat solver and not worry about it. The only one, like I said, I think we should redo the Paradiso for the PyMKL, because that's not really, there's been some issues and it's not being supported anymore. So we should just move it forward with our own sort of implementation. Or, I think we should do that step as far as Paradiso. That's what I mentioned. That's what I envisioned going forward with all of this.
Yeah, it makes sense.
Excuse me, Joe, did you say that Paradiso is no longer being supported?
The PyMKL the Python wrapper that we're using for it, that's interfacing with connecting Python to the Paradiso solver.
Yep.
It's not really being supported anymore.
Okay.
Dave Marchant wrote that.
Yeah.
Pinecale originally.
I don't think there's been any updates to it in like 3 years or so.
I think 2016 was the
He's
last.
in Julia land at this point, so.
Yeah. I had written my own Python wrapper for it at one point that I can hijack and pull in.
Cool, that's exciting, John. I'm really excited about this, and I think for as Dieter mentioned, for this paper, if we could even get a hacky version of this going, that would be excellent, because I think the Marlin model is going to be tough. So.
Yeah, no, I'll try out the Python wrappers there first for Petsy and see where that goes. And yeah, if I have to build it, I'm going to be building it. So yeah, we'll have something soon.
Cool. Joe.
Well, I have, so since last week, I've been hanging out in Leadville. A lot of people came to the house, and it's a very small house. So it's been kind of hectic here. I've done a few updates to discretize over. I got it all set up to automatically deploy everywhere now for a new update. So it'll go all the way to Conda Forge, like you were talking about, Dieter, they have the auto merge feature on there. It's got all the way through there. It was just a small little addition to the tree mesh plot image so that it'll respect a norm argument. So we can do things like plot log norms on the tree mesh and get reasonable color bars out of them. As part of that, I also went through and changed all of the keyword arguments to the plot image and the plotting functions for discretize to be in line with PEP8 conventions. So there is like p color ops is all lowercase now with underscore between p color and ops, things like that. As always, the old versions will still work. The old keyword arguments, it'll take them in and do what you expect it to, but don't expect it to last too much longer. As part of that, we do need to do I would like to do a whole pass on discretize and get it in line with PEP8 conventions. Yeah, and also I'd like to reorganize the modules in it a little bit, as far as there's a lot of like utility things that are exposed at the base level of discretize that are not needed to be. So just kind of hide those inside folders, things that we don't really need people to be looking at in the source code. It shouldn't change how anyone interacts with it, because those tree mesh or the tree mesh, tensor mesh, they're all going to be imported. Like maybe something to work on for the next major update for discretize, as well as, so once this, I still have the volume averaging stuff to get in. So maybe we can do that all at the same time. I don't know what people's opinions are on kind of switching over discretize to being all PEP8, but assuming people are in favor of that, a little bit of reorganization.
Very much so. And one thing we can even look at doing, I looked at this and then looked at how much needed to change, and then was like, we'll just, but doing flake 8 and things like that, so that moving forwards, people users developers get warnings and errors when we do something that's not PEP8. So yeah.
I was thinking about splitting up the docs on discretize a little bit more to be, so it kind of gets kind of confusing when all the same meshes and things are on the same page, like HTML page, right? It's one long list. I kind of like more like the NumPy style and things where you can click on, everything has its own page, HTML page. So I think we should move to that kind of doc structure at least. It's not going to change the lower level or the upper level. It's just the lower organization of it. So
Like just the API documentation? Or
Yeah, the API documentation.
Okay.
Yeah.
Cool. That sounds good.
Moving even in more NumPy style docs. It's almost there.
That's excellent.
Other than that, let's see. Last Friday, I signed a lease for a location up in Vancouver. So it starts on July 15th. So I think I'm gonna go for it on Sunday.
Yeah.
I'm gonna get a trailer. I'm gonna load it up and start driving.
What neighborhood did you end up in?
I got it in Kits on Broadway and McDonald.
Oh, sweet. That's a great place. You got all the restaurants and you're close to the beach and close to a grocery store. Yeah, and you're going to get addicted to Uncle Fatty's pizza.
I'm sure, I know I've talked to people and they're willing to get groceries for me, but I might need that in writing. John, I'm sure if you, I would appreciate if you could come drop off if you have some homebrew, I'd love to try it.
You're just in luck. We'll be bottling this weekend, so
yeah.
Good to go.
Yeah, that's all I got, really. I'll keep in touch with you guys.
Well, safe travels, Joe. I'm excited for you. Doug, do you have any updates?
Just one question for Joe.
Sure.
When you talked about doing the volume averaging, does that then solve the problem of going from any octree mesh to any other octree mesh or tensor mesh?
Yep.
It does the whole thing.
Yeah, it's completely arbitrary. It'll work on, I mean, I guess it might not work on curvilinear meshes and cylindrical meshes, but it should work for tree meshes and tensor meshes and arbitrarily between those two.
Perfect.
Yeah. It's a nice little solution. It's kind of the way it works is it looks for overlapping rectangles, and you can traverse the tree mesh recursively down to find everything that overlaps. You can do it in a nice way.
Well, you're the tree mesh expert, so that's great.
That
reminds me.
Speed, would it be relatively fast, Joe?
I mean, the tree search is log n kind of when you're looking for a cell given a point. So I guess it'd be n log n.
I see.
Right, that kind of operation complexity, roughly. Yeah. So it shouldn't be off. I mean, that's not a super bad complexity level.
Right.
So.
Right. That's great.
Yeah. As far as interacting with tree meshes, interacting with the tensor meshes, that one's already really fast. Like between two tensor meshes, because you can decompose it into each dimension.
Right.
Reminds me, I did a DOI. Soggy, I'm not sure if you looked at that GWB implementation of the DOI for the tree mesh.
Oh, actually, I was curious because I haven't looked at it because it's actually challenging now. In tensor mesh, it's simple because you can just search through each vertical direction, right?
Yeah.
But yeah, I was actually curious. I was kind of hoping to ask you in the GWB meeting, but I didn't. So how did you do it?
Take a look at it. It's really cute. It's really interesting.
Okay,
So
I'll take a look.
You can query the tree mesh for the cells, for the boundary cells on any side of it, right?
Uh-huh.
So you query it, get a list of the cells at the bottom, and then for each cell at the bottom, you look recursively upwards and divide into the cells.
Oh, I see. Huh.
It's a fun little algorithm.
That's pretty cool. I'll take a look.
I like recursive functions. They're fun.
Yeah. Yeah. Joe, you always got much better solution than myself.
I've got a couple updates as well. So yeah, I've been working with Dieter on this paper, and that's been definitely raising things about solvers, but also some cool things. And I'll share this. Well, I'll drop the link for the GitHub repo. I think Dieter's already put it in the Slack. So we've got a couple notebooks there for the block model and the layered model if anyone wants to play around with it. For the Marlin model, and this is something Joe, again, Octrees, and would be cool to get your take on. Right now, I've put together a very hacky way to basically go from the base, or like, so the Marlin model's on a mesh with like, I think 9 million cells. And so what I wanted to do is try and create an octree mesh from that. And so building that up, what I'm doing is actually just taking derivatives and like looking at basically where the model is changing. And then right now, just refining around those points. It's a bit of a clunky way that I've implemented it, but it's something that we can potentially build off of later on.
Is it on a regular mesh?
It is, I think so, yeah.
So it's like essentially you're using that regular mesh as the underlying tree mesh structure?
In this case, I'm not, actually. I'm creating a new mesh and then just feeding these points. We could think about using the regular mesh as the underlying structure.
Oh, and what you might be able to do is you look at each, you do the refine function, because you pass a cell or function that operates on the cell from the tree mesh. So you could just get the cell and then look at all the values that are in that cell and see if they're all the same. If they're all the same, then it doesn't need to refine or something like that. If there's any differences, break it down.
Almost clever.
Maybe.
No, you guys have to help first. For these notebooks and I'd be curious to get other people's opinion. But also actually on the layered model and the block model, if anyone wants to mess around and sort of see if you can get better accuracy, we're not doing too bad. I've been able to drive it down to sort of less than 10%. But still, when folks are looking at, if you're looking for 2 to 3% error, we're not quite cutting it. But I mean, something on the order of 6 to 10% is sort of where I'm settling, which isn't too bad. So.
We're is that everywhere, Lindsay? Is that far offset, short offset? What sort of, where do you usually get like high errors?
That's the mean. So let me see where these notebooks are. Yeah, I mean, there's definitely. I'll see if I've got one handy. It's just rendering on GitHub. Let's see if this one was okay. That wasn't the greatest. Actually, once you actually start fiddling and really driving it down, it tends to be sort of across the survey line. There's not like, it's not clear that like I'm really breaking down near the edges, or it's perhaps a bit more near the source. But I'll send a couple examples around in Slack afterwards, because I don't have it organized off the top of my head here. Let me just see, I'm just playing one more. Actually, this wasn't a bad one. So I think I was able to drive it down a bit further than that, but.
And this is frequency domain, Lindsay, right?
Yes, this is frequency domain.
And single frequency?
Yeah, single frequency. And so we've got, this is just a layered model. We've got some anisotropic, one anisotropic layer. This is in line with the source, and then this is 3 kilometers away. So, I mean, as you expect, like, you know, zero crossings and things like that. And then, of course, as we get a bit closer to the source, but.
I see. So it's actually the near offset, like far offset is actually like relatively low. Yeah. Okay. And what frequency is that?
Dear, this was what one?
I don't even remember. Yeah, something low.
Yeah, I probably didn't even print it. I don't remember offhand, but it is something low. So.
One thing that probably worthwhile to check is how other people handle like a kind of, there's a singularity in when you go to the low frequency. So if you like have a very low frequency, your I omega term is gone, then that coral matrix is actually singular. So one way the UBC approach was using the vector potential, like decomposing that into A5 solution and solve it.
No, but here we have the other examples from the other 3 codes. So right. I don't think, but it's not that low. It's like half a hertz or a hertz, so it's not that low.
True.
Let me try to find it.
Just a thought, like so if they actually implemented in the same way, solve
1 hertz. It's 1 hertz. Yeah.
E solution, then should be fine.
Yeah, I mean, in this case, like, I'm suspecting it's much more, I mean, because we're like, it's converging to the right solution. I mean, if you just eyeball this, we're doing not a bad job. It's now coming down to sort of mostly discretization and probably interpolation errors. Like, I suspect, actually, if we had a second order interpolation on receiver.
That's the thing.
Further.
Yeah. Yes.
Oh, in space.
Use cubic.
In space, you mean?
Yeah, in space. Which maybe actually that's where I should focus efforts rather than.
Yes, because when I started to write my code, which was based on this other MATLAB code, I did this comparison between, he used linear interpolation, and I just found the error is way too big in EM.
Yeah.
Particularly if your cells are not super fine.
Yeah.
So that might actually be a huge difference.
Okay.
I mean, but if you like directly define on the edges, for instance, then like where you actually solve the solution, then it should be like, I don't know, I like it'll be worthwhile to check, Lindsay, because if just move the receiver at the location where you're actually solving, getting the solution. So like on edges.
This I believe should be on edges, and so I think the mesh aligns there.
Then I
don't think spline interpolation would help that.
Yeah.
Like Dito, are they used actually like higher order finite elements or finite volume?
So the other ones?
Yeah, we're using like a first derivative, like at the end it's a second order, but in terms of difference, it's a first order difference.
I'm not actually familiar with unstructured meshes terminology, but they roughly use the P1 and the P2, and then he stuck with the P2 result. So I think this is second order polynomials, but it's way out of my comfort zone.
Okay.
What that actually implies.
So if it's a second order polynomial, then so first order polynomials and finite elements usually yield second order convergence. So
yeah.
Gotcha. Okay.
Cool. Yeah. I mean, so at this point, I'm not like unhappy with these results. It would be nice to drive them down a bit further, but it's comparable, and like, yes, SimPEG is slightly above, but yeah. So, but if anyone wants to mess around with meshes and things like that, you're welcome to play around with these notebooks.
Yeah, that looks good.
Cool. And then the other thing I wanted to share with folks is I had a great conversation with Peter Liliev earlier this week. And he is starting a position as a professor in the math department at Mount Allison. And so he's right now kind of just exploring the open source space and trying to see, you know, what tools does he want to really start getting familiar with and maybe start pointing students to. So he's been checking out both SimPEG and PyGimli. And he's really interested in unstructured meshes. So coming from sort of, you know, the work with Colin, a lot of what they've done is unstructured meshes. And so one of the things I wanted to put out is that I think that that actually could be a really cool opportunity for us to think about implementing unstructured meshes, one, but then also to actually start like interoperating a bit with PyGimli. Is even if we don't actually like tie those code bases together, at least if we could like take a mesh and load it both into PyGimli and into SimPEG, I think that would be really cool because we could actually start sort of comparing, like really actually comparing inversion results and things like that, because we both take very different approaches or fairly different approaches, but being able to be on the same mesh would be really cool. So yeah, so I think Peter might be able to join us next week. I let him know about the SimPEG meetings. So yeah, so that's just something on the radar. And if there's anyone who's particularly interested in unstructured meshes, we can even slowly start kind of sketching out what that might look like in SimPEG. So.
Yeah, I'm definitely on board with implementing like unstructured meshes on SimPEG. We don't really have to, we shouldn't concern ourselves with generating the structured or the triangulated meshes, but we should at least be able to, given a structure, we should be able to handle it.
Yeah, yeah.
And then we can take into account like nice things like boundary conditions, get really fancy with it.
Yeah.
We can do some of those things like we were talking about, having interior boundaries.
Yeah.
Oh, and I guess maybe one last request is if folks, what I'm going to try and do is pick like an hour a week to just take a look at discourse. There's some stuff that's been there for like a month and I've dropped the ball and nobody else like spoke up on that comment, and that's fine. But if we can all even just take like, I don't know, tackle one a week or something like that, that would be wonderful, and I think would spread the load. I can look. I think there's a way to have discourse ping Slack. I don't know how to do that, but I think it can be done, which might be helpful because I know we're all sort of on Slack and tend to answer questions there. So if there's a way that discourse just like notifies us that there's a new question, I think that would be good. So I will check that out. Yeah.
Yeah. I'm glad that I haven't been able to keep up on it. Might be a little hectic.
No, and it shouldn't be any one person who is like in charge of triaging all of discourse. If we can all kind of, I don't know, or even if we need to like take a rotation or something like that, we can figure something out. Yeah. Any other thoughts, questions, items? Thanks everyone. Joe, I guess the next meeting we see you, hopefully you'll be in Vancouver, which is really exciting. So safe travels.
And I think Dieter and I were gonna do something right after the meeting to try and fix like an import bug that he was having. So I don't know if you want to leave this open or if Dieter, you want to just separately do a chat somewhere.
I know, Lindsay.
I can leave it open. I'll stop the recording and then you both can take over.
Great.
Yeah, cool.
All right. Thanks everyone.
Okay. Thanks, Lindsay. Thanks, everyone.
See you later.